مساء الخير. احنا هنبتدي دلوقتي، بس قبل ما ابتدي انا عايزه اعمل كويك تشيك على الصوت لو في مشكله. تمام. اوكي.
تمام.
تمام. ميرسي يا باشمهندس. Good afternoon, ladies and gentlemen. Welcome to Ecology webinar titled Introduction to Measurement and Verification for Energy Efficiency Retrofit. Today we will learn about measurement and verification, M&V, best practices. Also, we will have an overview of the different M&V options under the IPMVP, and we will be able to understand the benefits, risk reduction, and performance increase through proper measurement and verification of your energy efficiency projects. We are delighted today that our speaker is an expert with a great experience in this field, Engineer Hassan Younes, co-CEO and founder of Griffin Global Consultants. I would like to welcome you. It's a great honor for us to host you today in our webinar. We will start with the speaker bio, then a quick overview on the agenda, and finally we will be pleased to answer all your questions. We will be collecting the questions during the webinar in the Q&A box. Also, we will share our contacts for any further discussions or meetings. And finally, the webinar material will be sent on the registered emails, so please make sure to remember the registered emails very well. هنبتدي البرزنتيشن بتاعتنا دلوقتي. I will share the bio. Our speaker today is Engineer Hassan Younes. Hassan Younes is the co-CEO and founder of Griffin Consultants, a multidisciplinary consultancy, and has over 15 years of extensive experience in the field of energy efficiency, design, sustainability, and project execution and management. He is also involved in many high-end projects in the MENA region, encompassing MEP design, energy efficiency, commissioning, management, sustainability and measurement, and verification for new and existing buildings in the MENA region. He's also involved in energy and sustainability policy studies for many governmental entities in the GCC. He's also professional technical trainer, experienced at ASHRI Global Training Center, Association of Energy Engineers, Certified Energy Managers, CEM course, Energy Valuation Organization Certified Measurement Verification Professionals, CMVP course, facilitator for the Emirates Green Building Council Building Retrofit Program. He is also appointed the consultant for ASHRI 62.1 standard. Engineer Hassan also is a member of the training committee for the CMVP course. And finally, but not final, he has a great bio, but we made a shortcut for it today in our webinar. He was the ASHRI Falcon Chapter past president and on the technical committee, and was the vice chair of SIPSI Regional Chapter. Hassan holds all the ASHRI certifications, and I'm sure there are a lot more to come. Our agenda today will be as following. We will start with the fundamental factors driving the energy savings, then discussing what is the M&V. After this, Engineer Hassan will discuss the M&V options as per the IPMVP, and then the M&V squabbles. And finally, Engineer Hassan will discuss why an independent consultant and M&V reviewer. Finally, we will review your questions, so please make sure to send your questions in the Q&A box during the webinar. Engineer Hassan.
Thank you, Engineer Shaima. Hello, everyone, and welcome to this webinar. I'll start sharing my screen now. So today we'll be talking about measurement and verification. Around the MENA region, a lot of new projects on energy efficiency, whether it's for new buildings or for existing buildings. The idea behind the seminar today is just to go over a brief introduction to M&V and basically take you through some of the IPMVP requirements and also some of the issues that you need to be aware of when you're doing measurement and verification. First, let's just go through a brief about Griffin. Griffin is a multidisciplinary consultancy that delivers energy efficient and sustainable engineering, design solutions, advisory services, and our purpose is to serve our clients and the well-being of their local communities. So we have expert team of designers, engineers, technical consultants. We have certified people. We actually have trainers as well. So I'm one of the trainers working with Griffin. We also have 2 other trainers for CMVP and for CEA. Throughout the years, we've collected some awards. Some of them, the last one was the SIPSI Building Performance Awards Retrofit Project of the Year, which was the Abu Dhabi Department of Energy Pilot Retrofit Project, which is actually going now through the 2nd year of measurement and verification. So that is an actual project that is related to what we're talking about today. We work under like 5 verticals. We have the energy efficiency, sustainability, engineering, interior design, and small architecture. So if you feel that we can help you in any of those fields, please feel free to contact us. Sectors that we cover: infrastructure and district cooling, high-rise buildings, low-rise buildings, villas, oil and gas, retail, food and beverage, and corporate. Some of our clients, we have worked with Emaar, Nakhil, Tabreed, Miras, GEMS Education, Al Futtaim, Etihad Energy Services, Masdar, and many others. You can see all these on the screen, and we'll share with you the presentation anyway. Now let's get right into the subject. First, let us discuss what are the fundamental factors that drive energy savings. And we'll talk more here about like an existing building as an example, and you've done some retrofits. Let's say you've changed your air conditioning system into a more efficient one. As an example, you had a very old air-cooled chiller that was like 20 years old, and efficiency dropped down drastically throughout the years. And anyway, the efficiency of the 20 years ago was much lower than what you get if you buy a new chiller today. So there's a great deal of efficiency change if you change that old chiller into a new one because of the degradation, plus the factor that you have better technology nowadays than you had 20 years ago. So to determine energy savings, we need to look at 2 aspects. One is the KW, so how much are you using, and how much time are you using it for. So 2 things will affect the energy consumption. Let me just get a pointer. So you have the reduced operating hours. Let's say for whatever reason, in summer it's a school, let's say, as an example, and it's totally shut down in summer. So you can theoretically turn off the chillers during summer. For whatever reason, the owner was keeping the chillers on and the air conditioning system on, and it's not needed. So you just can reduce the consumption by turning off that chiller. So you can reduce the energy consumption by simply reducing the operating hours. On this side, this is mainly due to the improved performance efficiency. We had a COP of, let's say, a kilowatt per ton of 1.8, and now we've went down to an annual efficiency of, let's say, 1.2. So we have a good amount of difference between the old inefficient chiller and the new chiller. And these savings here are mainly coming from the reduction of, or the improvement of efficiency. This is mainly coming from the reduced operating hours. So when you do energy audits, you will look into reduction of operating hours. So if you look at lights as an example, you find out that sometimes some of the lights are on, should not be on during certain times. So just turning them off will get you instantaneous savings. Other things that you might look at that we normally find are being used and they're not needed. Fans, parking fans. Sometimes you find that the office building or the mall just turns off at night and the fans are still on. So any of those findings that will reduce operating hours basically are in this area. Anything that's improving the efficiency, that will basically be this area. Now, what is M&V? I think there was a seminar here done before, a webinar on energy efficiency, energy conservation measures. So once you've done those measures, you've changed your chiller or turned off the lights when they're not needed, or changed the lights or added the control system, we need to quantify these savings. And it's not as easy as you think it might. So one option is just looking at the bills. So as you can see here, looking at comparing Jan 2000, let's say 19 to Jan 2022, when we actually did the retrofit. And if I just take the subtraction between the consumption of these 2 months, I'll get the difference. But that doesn't mean these are the savings, because whatever I was doing in 2019, the factors that are driving energy consumption might be a little bit different in 2021 or 2022, whenever I've done the retrofit. One example could be weather. Weather could be different between this January and that January, and that will cause a different pattern of energy consumption. We cannot compare apples to apples if we don't take this into consideration, that maybe in Jan 2019 it was a bit colder, and the energy consumption is comparably higher than 2021 or 2022, because Jan in 2021, let's say, was a bit warmer. We didn't have to use our boilers as much. So in order to do this apples to apples comparison, we need to bring both the baseline period and the proposed or the reporting period to the same factors. So as per the IPMVP is the International Performance Measurement and Verification Protocol that is developed by EVO. And the latest version was 2016. There'll be a version that will be released very soon. I actually got the draft like a week ago, and we're currently reviewing the document. It's almost like 95% complete, and it should be published within this year. But the definition of M&V is basically the process of planning, measuring, collecting, and analyzing data for the purpose of verifying and reporting energy savings within an individual facility resulting from the implementation of energy conservation measures. So M&V is basically all that. It's the process of planning, measuring, collecting, analyzing data for the purpose of verifying and reporting energy savings within one individual facility resulting from the implementation of energy conservation measures. Now, the issue with savings, that we cannot directly measure savings. We can measure energy consumption and analyze measurements to determine savings. We cannot come up to the savings because they're not there. It's just basically reduce energy consumption. So we cannot directly measure the savings. And how we calculate the savings, basically looking at the baseline period energy, and the baseline normally is taken to mimic a full cycle of that process or of that building. So for a commercial building, that's normally 1 year because you have different weather throughout the month. So 1 year will be like at a cycle. And then you compare 2019 full year, let's say, to 2021. It could be a factory where you have a production line that is doing the same thing every day. You might have only weekdays and weekends where there are differences. So in that case, maybe 1 week is enough to be the baseline period. So it really depends on the process and what you're trying, what you're applying M&V to. But for most buildings, it's generally 1 year. So even if you're looking at a chiller system, especially in a place like in the GCC where you have a lot of chiller consumption, or the chiller is being used for most of the time, so a full year might be required to capture the baseline of that chill water system. So the equation from the IPMVP is to calculate the savings is the baseline period energy minus the reporting period energy, plus or minus adjustments. This is the difficult part here, is adjusting the baseline period energy consumption to the reporting period factors. So what are we, let's say, in the reporting period, one thing that I've mentioned before could be weather has changed or the temperatures have changed. So I need to ask myself this question: what would have been the baseline period energy consumption if the weather during that period was the same as the one we are experiencing in the reporting period? So I need to come up with the answer to that question and say, well, it would have been this much, or these are the amount of adjustments needed to bring the baseline energy consumption to the corresponding reporting period factors. So here you can see a representation of the baseline energy. So let's say this is a full year, and you can see maybe in summer, the consumption is a bit higher because you have running more air conditioning units. And this is basically after the energy conservation measure has been done, installed, and commissioned. You can see that this is the adjusted baseline here, which means that we have updated the baseline energy based on the current situation we're facing in the reporting period. So whatever factors have changed, we have applied that to the baseline energy, and we have updated this baseline energy. As an example, let's say it's a factory, and in the baseline, you used to produce, let's say, 1,000 units of windows. Let's say this is a factory that produces windows, and you used to produce 500 units per week, and now you're producing 750 units per week in the adjusted or in the reporting period, because you have altered maybe the shifts, and now you're working more. So the consumption for the baseline, if we had 750 units being produced at that point in time rather than 500, the consumption would have been more, which is represented here by this adjusted baseline energy. Otherwise, let's say you are the energy service company, you've done your energy conservation measure, and now the client's supposed to see some reduction, but the client has increased the production from the facility, from that particular factory, and now they're seeing that there's not much of change in terms of energy consumption. But you can tell the client the problem is that you've increased the consumption or the production. And in that case, if the production in the baseline period was as what we have in the reporting period at 750 or 1,000 units per week, the consumption would have been higher. So this is the whole purpose of doing these adjustments, is to have a fair apples to apples comparison. Now, moving on to the M&V options as per the IPMVP, we have 4 options. 2 options, which are options A and B, fall under the retrofit isolation methods. And basically what we're trying to do here is we're looking at the energy conservation measure and drawing a boundary around it. So as an example, if I change the lighting in a building, I will look only at the consumption of the lighting before and after. I wouldn't care about what's happening in the building elsewhere. So in that case, I have limited the location of measurements and analysis that I need. I just need to analyze that portion of the building. Now with an option A, it's kind of the best option to be used maybe for lighting, where you kind of know the schedule. So you don't expect the schedule of lighting, meaning the time schedule will be different between the baseline and the reporting period. So the amount of time the lights are on or off is kind of the same. So they're not changing the function of the building. You'd expect the lighting to behave similarly if you're only changing the light bulbs. So we're only changing the light bulbs in this case. I'm moving, let's say, from CFL or from fluorescent to LED. And that will basically drive the energy consumption down. The number of hours, they'll probably be the same because the function in the building has stayed the same. So with an option A, I'm only required to measure the key parameter. So what is the key parameter in the lighting change? So if I'm changing the lighting fixtures, it would be the consumption or the power of those lights. What was the power consumption before the change, and what did it become after the change? And I can look at it, light bulb or fixture by fixture. I can look at the dB level if it's connected to multiple fixtures. And there are some sampling procedures within the IPMVP, so you don't have to like measure all the fixtures. You can do a statistical analysis, and based on the number of population, you can get the number of required samples to be measured with a certain confidence level. We're not going to go through these details in this short presentation, but all these are available in the IPMVP. So for an option A, it's the simplest retrofit isolation method, because it only requires, let's say, a key parameter measurement. So in this case, for lighting, it would be the power measurement of the lights. And then you'd say, well, we know from the energy audit that we've done some measurements on the schedule, like operating hours for these lights. So we know that lights in the main office hall are used from 7 a.m. till 5 p.m. So we're not going to change that. And we're going to just assume that these values will remain the same. So we've measured the consumption before and after. We multiply by the number of hours. We have now the consumption during the baseline. We have the consumption during the reporting period, and we just subtract these two numbers, and that will give us the answer of how much we've saved. Now, there's a level of inaccuracy, obviously, here, because we're not measuring the amount of time. But again, that's a risk that the client and the ESCO will take into consideration, and they'll decide if that's the right option to go for. And normally option A is kind of the best option for lighting projects. With an option B, we need to measure all parameters. So we need to measure the time and the power. So in that case, we need to put also maybe a constant power meter or a power meter that is that's going to be there measuring these parameters for the whole period of the reporting period. So we have a permanent meter that will be measuring those the lighting power, and basically that will be more accurate because we're not doing any assumptions here. Option B is normally used for any energy conservation measure that has a varying load. So let's say a pump with the VFD, that makes sense to have an option B because the load is not constant all the time. So you might have see changes there. If you had, let's say, a fan that is running 24/7, as an example, it's, let's say, fresh air for, let's say, a hospital, and is constant flow for this example. So no changes happening in terms of the flow changes. And then you are basically replacing it with a new fan that has better efficiency and maybe a better motor has better efficiency. In that case, you can probably use option A. Option B will not, will be more expensive and really will not give a lot of or much better results than option A because it's a constant flow system. But whenever it's not, then option B becomes important to have compared to option A. So option B will basically be more expensive, but it will give you more certainty. It will be more accurate in terms of quantifying the savings. Now, option C, which is a very popular method, is to basically look at the whole building. So looking at the buildings and looking at the utility bills and comparing the old utility bills to the new utility bills, plus the adjustments, obviously. And that normally happens when you have a multitude of different energy conservation measures. Then option C becomes probably a better option than option A or option B. And you normally would use it if the reduction expected is more than 10% of the whole facility consumption. Below that, it will be very hard to quantify the savings. Option D is a calibrated simulation. it normally is used for new buildings to kind of quantify how much you'd be saving if you are applying, let's say, LEED version 4 or LEED version 3, or applying certain energy conservation measures on your new building compared to the code requirements. You can compare how much you've saved compared to the code requirement. We're not going to go into details into calibrated simulation. It requires an expert energy modeler, because normally that work is done on an energy simulation software. I'm actually also working with the Option D subcommittee to come up with a kind of a guide of how to use Option D. Till now, it's rarely used, mainly because it does require a lot of expertise on energy modeling, and it normally will only be used for existing buildings if you don't have any data on the consumption. You just want to create a baseline model from scratch. But it is very impressive because you'd have kind of a simulation where you can, try out different things on the building, different energy conservation measures, and if you have any adjustments, it would be easier to do these adjustments using this calibrated energy model. Now, we're going to go through some M&V squabbles, some problems that you might be facing with the M&V, just to show you like what kind of issues you might find. So this is basically, it was a case where a bill-on-bill negative savings. And the issue is that the client was seeing those bills and comparing year on year, they have zero savings, or actually negative savings. And the ESCO was saying, well, there has been some changes in the building, and this is why we're not getting the savings. Looking at what the client was saying, they said we didn't have any change in occupancy. It's like very basic, a change. Maybe we've added like a couple of more employees, but that was nothing drastic. No change in other static factors. Static factors are basically factors that are not, you don't predict that they will be changing. Like, let's say, occupancy, you'd expect the occupancy to be the same. If it changes, then it becomes a non-routine adjustment. So you need to still work it out and see how much the effect would that have been on the baseline. Weather was very similar also in this particular case. So there was no reason for negative savings. The only reason was that the ECMs that are being used were not very effective. Now, what did the ESCO try to do in this case? And this is why it's very important to have a third-party review. They said, well, let's do a temperature adjustment model. And they've told the client that we told you to put this thermostat at 24 degrees C, and you're putting at 22 or 23, and this is what's causing the negative savings, which is not true at all. One reason being that during the baseline, the set point was at 21. So if it's now at 23 or 22, we should still see some savings because the baseline was at the worst condition. It was at 21 degrees C set point for air conditioning, which means it will use more energy compared to the current reporting period where the temperature is set point at 22 or 22.5 to 23. So they had this in the M&V plan. Unfortunately, we got assigned to the project after this M&V plan was approved and signed by both parties. And what the ESCO is saying, well, if you reduce from 24 to 23 degrees C, as an example, we increase 11% of the total energy for the baseline, which again is not accurate because the baseline was at 21 degrees C versus the reporting period was at 22.5. But in the M&V plan, they had this number 24 degrees C, that whenever the temperature goes below 24 degrees C as in set point temperature, they increase the baseline by 11%. Same thing for the occupancy adjustment. They say, well, if the number of hours have changed, then we just divide total electricity consumption divided by number of working hours and multiply by additional working hours. We all know that adding, let's say, 1 hour in the evening is very different in terms of energy consumption than what's happening during the midday. So we cannot have this linear relationship between the occupancy versus or the additional working hours versus consumption. So again, was a very bad simplification of the problem. And as you can see here, if we just do an example and say, well, if I put the thermostat at 18 degrees C compared to 24, then the energy consumption would jump by 66.33%. And if I add 4 hours in terms of working hours per day, then I increase the consumption by 33.3%. So if I do both, I have increased the consumption, the baseline, by 100%, which doesn't make sense. If you put your thermostat at 18 degrees C from 24, it's not going to add 66% energy consumption. So that was one of the issues we found in this building, and the ESCO was just trying to, save on the contract so that they don't have to pay for the guaranteed savings. They don't have to pay that penalty because they were not saving any energy. So we need to be very careful when you're doing these M&V plans or reviewing any, because we've seen that, and a lot of projects do go through that. Project B, lawsuits and conflicts. So yeah, it happens. And in this particular case, we were brought in to assess a situation, give a technical report, an unbiased technical report, and show who is at fault basically from a technical point of view. ESCO was saying that they are adhering to IPMVP requirements, but that was not the case. Savings that were shown was much higher than what was achieved. The owner, since the owner does not have a lot of experience and knowledge about M&V, they were at first approving their bills and invoices without looking into it. And then when they found out that their energy bills in 2 years have not changed or actually increased in those buildings, they got really upset about that, and they started checking with the ESCO on these things, and then this ended up in a dispute, and they went into this long process of dispute arbitration. So some of the examples here, assuming unreal savings for some energy conservation measures, mentioning option B and only use deemed savings. So option B requires to put meters and measure all the parameters. They had nothing. They were just basically saying, I'm going to install, a VFD on this pump. I'm going to save 60% of its energy. And they're just saying the baseline was also calculated. Some of them were measured for like small periods of times. And they come up with the baseline and say, I'm saving 60% of that without any validation from actual site measurements after the implementation. What happened later was that the owner noticed that his bills did not reduce, and on top of that, he was paying savings to the ESCO. Problem later escalated to arbitration, tens of millions of dirhams in that particular case. Had the owner hired an independent consultancy from the beginning to review the reported savings, that could have been avoided and could have been caught from day one. So very important also to determine these needs from the get-go, and it will protect both the ESCO and the client, because at the end of the day, sometimes the ESCO will have to pay for all these things if they are found to be defaulting. So it's much better to have an independent M&V consultant from the beginning, review the M&V, so on and so forth. Some other projects that we've seen as well, some problems with the M&V. Some examples could be like an ESCO applying adjustments to fresher hand units energy consumption due to increased operating time. So basically, what the ESCO did in this case, they've used the nameplate ratings rather than the actual consumption. So if you go, let's say, into a nameplate, you'll find that the motor has this much of kW, and actually that's the mechanical kW. So they've used some equations, let's say using the mechanical kW times some load factor, and they've used that as the basis for the consumption of the electric motor on that fan, instead of actually doing some doing some measurements and calculating the savings in a more accurate way. So IPMVP does require savings. ESCO not applying occupancy adjustments. So we've seen that mostly also during the COVID. So in some offices there was, no people or just few people, and then the ESCO did not do the adjustments for the occupancy. ESCO reported water savings, and then we later found out that the water fixtures have been removed, or the aerators and the flow reducers have been removed by another contract. Now, it was not the problem from the ESCO. It's basically someone had removed them. But as part of the M&V, the verification part means that you need to step into the site every now and then to make sure that these systems are set in place and are working properly. So it's also very important to do the verification properly, to go to site and check on the different systems to see that they are still working properly. Now, why to hire an independent consultant? It does protect both the ESCO and the customer. We're also involved in a project at the moment where they also have a problem between the ESCO and the client. The client is saying, whatever you're showing us in the reports doesn't make sense to us. We don't think you're doing that much saving. Why should we pay you this much? Because it was a shared savings agreement. So our role here is to look at the audit, look at the M&V plan and the reports, and give an independent opinion to both the ESCO and the client, and also work with them in future to review these M&V reports, make sure they're done in an accurate way. In energy efficiency projects, we do recommend to have an independent consultant because it will help in managing the RFP and proper selection of ESCOs. Instead of going with one ESCO, you can have a proper RFP and then have a proper selection done with the help of the consultant, help in the contract writing and negotiations, especially in terms of pricing. It does help to have a competent technical consultant on board to see the costs that are involved, do they make sense or not, and give comments to the ESCOs so they can revise that. Also, it helps in making sure that the energy audit done by the ESCOs is done properly, no ECMs are missed, and no snake oils being proposed. You can see sometimes some of the ESCOs will come with any technology that hasn't been proven yet, and they want to push it to the project, and some clients might not have the technical expertise to understand that this is actually snake oil. It's not going to work. So having an expert consultant on board with these projects will help in eliminating these risks. No exaggerated savings. Some ESCO will come and will claim that they're going to save a lot, and mainly they do it, I guess, to take the projects, and then they'll try to get out of those in the future. Those savings that they've signed on, or then maybe during a later stage they can reduce it. That will also, be a disappointment to the client if the savings that have been put in the contract were not achieved. Proper supervision on site. So these ESCOs, at the end of the day, they're contractors. They will need to do some modifications on site. Having an expert consultant on board to make sure that they've done things in a proper way, health and safety, code requirements, technically sound. So having just like in a normal building project, new buildings, new construction, you always need a consultant. You cannot just let the contractor just give them the design and let them run the whole project on their own. You need to have a supervision consultant that will look after the project from a site progress point of view. Also managing variations. If there are any variations that are being asked by the ESCO for whatever reason, the consultant will help in managing those variations. Now, as per the IPMVP, it does state that the owner needs a independent verifier to review the savings reports. The independent verifier should be helpful to ensure measurements validity and prevent conflicts. And if conflicts arise during the reporting period, the independent verifier can help resolve the conflicts. So basically, according to the IPMVP, the independent verifiers are typically engineering consultants with experience and knowledge in the energy conservation measures, M&V, and energy performance contracting. So whoever need to be hired will need to have understanding of the engineering part of it, the project management part of it, and the measurement and verification part of it. So why do we need an M&V reviewer? That should be independent, avoid future conflicts between both parties, make sure energy efficiency is attained and vetted by a third party, and to help the ESCO and the customer in preparing a robust M&V plan and perform M&V activities properly. It's also a requirement in many countries' public programs working with the government. In general, they would need an independent M&V consultant. So let's say in the case we're working with the Abu Dhabi Department of Energy on the pilot project, we are the independent M&V reviewer in this case. So, I mean, that's it for me today. Thank you all for attending. This is my email. If you want to send any questions, if you have any inquiries, or you have any projects that you think we'd add value to, please send me an email. And I think on to you, Engineer Shaima.
Thank you so much, Engineer Hassan, for this great presentation. We all have learned a lot from it about the M&V. I will share now a quick review about ecology. Meanwhile, I appreciate if anyone has any question, just send it in the Q&A. We will answer it after the video. As we all see in this video, we are in 365 Ecology, are proud to announce that we are now having sister companies to complete our company profile, like Eco IFM for facility management and Zaldis Technologies for complete contracting projects. I will start now with the questions part. Okay, we will start with the first question. Someone is asking, how can we determine if a new chiller to be supplied is most efficient, especially a lot of manufacturers in the market?
That's a really good question. And to answer this, it really depends on the climate and on the situation. But in general, we want to look at not just the, let's say, the efficiency at AHRI conditions or at a certain condition, or even the IPLV or the looking at the NPLV. These give a part of the picture, but not the whole picture. The best way is to look at a performance map for the chiller and do a simulation, and then actually get the get the consumption in both cases to see which chiller is better in terms of energy consumption. So looking at the IPLV or the NPLV can give you an idea of the which chiller is better, but to get really a very good idea, doing an energy model, and you can either do it on Excel sheet or in a energy modeling software like IAS or Design Builder. So what you can do is put that map, and then you can do an hourly analysis. So an Excel sheet, you can just look into or come up with a profile for the building. So if you have the tonnage for the building hour by hour, or you can come up with a realistic one for the building, you can put it hour by hour. You can put the outdoor temperature, and then from that you can come up with the consumption hour by hour from the map that you get from the power consumption map you get from the supplier, and then apply that on hour by hour, and then get the total consumption per year. Put the second chiller or the other option from the different manufacturer and do that exercise again and compare both. You can simplify that by using an energy model, and that will normally be a bit easier to implement.
Okay, thank you very much. Actually, we are receiving too much questions. We will be answering as much as we can. The second question is, can you share some approach on how to calculate or arrive at adjusted baseline consumption for ECMs under option B? I think he means project B.
Yeah, so option B for the M&V, again, it will really depend on the situation. So what is the ECM first? If it's lighting, it's a pump, it's a chiller. But let's say, as an example, it's a chiller. Let's say it's a water-cooled chiller. And the adjustment is going to be done because the cooling tower has changed. The temperature on the condenser has changed. And that's basically driving the energy consumption and the proposed, let's say, a little bit higher than it should be if it was under the same conditions the baseline was at. So let's say the temperature was set at 29 degrees C for the whole year. Let's say this project is in Cairo, and the set point for the cooling tower, just as an example here, is 29 degrees C for the whole year. And that was the case in the baseline. That was the case. And the energy service company did decide to keep that control in place. They just changed the chiller, and the temperature should have been always 29 coming out from the cooling tower entering the condenser. But for whatever reason, the cooling tower is not performing properly, and now it's kind of sending the temperature at 30 and 31 degrees C. So what you need to do now is go back to the baseline and say, if the temperature was 31, what would have been the consumption of that chiller? And then you would go back to the performance map from the energy audit to see like at different temperatures, or you can look at the suppliers data and tell the client, well, we didn't do, let's say, the mapping during the energy audit, and we might need to rely now on the performance map from the supplier, and then again create this Excel sheet saying the consumption should have been this much in the baseline with this new load that you are facing in the reporting period and the new condenser temperatures. And that would be your adjusted baseline for this particular case. Again, every case is different.
Okay, thank you very much. We received also another question about what are the softwares used for the simulation in case of M&V retrofits?
What software? I mean, yeah, so we use a lot of energy modeling software like IES, Design Builder, even HAP and TraceTrain. They have some capability there as well, but they're not as powerful as, let's say, IES and Design Builder. There are some other software like RedScreen that is more of a, could be used for M&V as well as computing savings. So RedScreen is done by the Canadian government. So that's also a software that is interesting to be used for M&V.
Okay, thank you. We have another question. What sectors do you think are the low-hanging fruit for EE retrofitting projects?
Well, it depends on which area. So if, let's say, we're talking about Egypt as an example, I would say industrial, commercial buildings, normally they will have a lot of opportunities. Residential, not that much, because unless you're in a building where you'd have a lot of common areas, let's say air conditioning units, which in most buildings you don't have, but let's say I've seen them in next to to Cairo Festival City, and the new buildings there, they have some fresh air handling units they can look at, pumping as well, fan coolants in the corridors. Commercial buildings, malls, hotels, these would be great to look at, as well as industrial. Government as well, government office buildings.
How much power saving if we use PICV instead of normal balancing bulbs?
Well, that really depends on the current situation. So you might get zero savings from adding PICVs. You might get some savings from adding PICVs. So the PICVs might help you in reducing the delta T, or improving delta T, or reducing the low delta T syndrome. But it's not definitely an answer where you'd save energy. So it's not always, it's not 100% guaranteed that you'll save. But what you normally would save on is the pumping power and maybe some of the chiller power, because you load the chillers better if you have better delta T. So it depends on the current situation, but it's a bit hard to compute the savings you get from the PICVs. You need to do a lot of analysis to see how much you'd be getting in terms of savings. Could be 0% in some cases.
We received another questions about the ECMs. Someone is confirming that he understands that the ECMs, it would majorly consider the demand in kilowatt and the operating hours, but what about water ECMs? How would you measure the water saving?
All right, just going back on the previous question for the PICVs. So for the PICVs, in order for them to work, you need to have VFDs on the pumps. If you don't have VFDs on the pumps, you get zero savings. If you add VFDs on the pumps, then or you have VFDs on the pumps, you'd get some more savings. Now, regarding water savings, very similar to the energy savings in terms of, like, you can look at the bills before and after and do adjustments. For an option A, which is normally used for fixtures, so you can take the measurements, which is pretty easy. You can just get a bucket that has a, you can measure with it the flow of water, and then before the change, and then once you change the fixture, if added an aerator or flow reducer, you can check the flow after, and then you can say, this is being used 3 times a day for 1 minute or 2 minutes each time, and then you can calculate the savings. And normally we use an option A for the water savings. Again, when it comes to water fixtures.
I guess we will have one final question to be committed with the webinar time. And if anyone has any more questions, he can contact Engineer Hassan directly on his contacts, and we will be sharing the webinar materials with you. The last question is about the ESCOs. Someone is asking, what are the necessary qualifications to accept the ESCO?
So different government entities would have different requirements, but in general, they need to have the technical expertise. So some would look into some certifications like CEM or BAP from ASHRAE as a requirement. Also, they need to look at their financial statements to see they're capable or not in operating their team. They have the contracting experience, so they have any partners. They need to have a CMVP on board as well. So looking at the size of the company, their financial capability, their technical capability, certifications is normally what the regulators would look into.
Okay. I guess we have 1 more minute to answer another question, short one. Someone is asking, what will be saving if we replace chillers with new chiller with BFD?
So that's a 1 million dirhams question, because we actually did a study for one of the district cooling companies here, if you change, let's say, water-cooled chillers, and or if you add VFDs on the water-cooled chillers, how much saving you'd get. And in that case, it varied between maybe around 10% savings. It depends on the weather. So that particular project we've done or study was in the UAE. So it's pretty humid country. And I think when we added like VFDs to all components, like primary condenser water pumps, as well as, normally we'd have them on the secondary and on the cooling towers, then we got around maybe 16 to 17% in terms of energy savings.
Okay. Thank you very much. We will not be able to answer more questions. So if anyone has any more questions, he can contact Engineer Hassan directly on his contacts. And finally, I want to thank you very much, Engineer Hassan, for your time today. It was a great honor to host you. The material is really great. Thank you very much. The material is really great and rich material. We all have learned a lot from it.
Thank you very much. And I hope everyone enjoyed the webinar. If you have any questions, you have my email. Please send me an email then.
Sure. We will be sharing the webinar material on the emails. And if anyone wants to ask more questions, he can contact Engineer Hassan directly. Okay, thank you very much. And many thanks for all the attendees today. Looking forward to see you all again in many webinars. Thank you very much.
Thank you.
Thank you, see you.